Hi again everyone, Chris Tisdell here again. In this presentation, I'm going to continue my series of videos on complex numbers. Now in previous videos, I introduced the idea of the conjugate of a complex number, and I've done some basic examples. In this presentation, I'm going to continue those examples, and I'm going to show you a slightly more involved example that takes a bit more time. So I've decided to devote a video to this particular example. So let me share my screen with you and we can start. Okay, so here's the problem I'm going to work through. Suppose the imaginary part of this quotient is 0 and the z, whatever the complex number is not equal to I. Show that the real part of z must be 0. In other words, you want to show that z is purely imaginary. So it'll be like of the form, say, bi. Now, this is a difficult problem because it's not clear where to start. But before I do start, let me just sort of just share with you. This is sort of a curly I, if you like. And some books write it IM for the imaginary part. This sort of curly R is sometimes written as RE. Okay, the real part of Z and the imaginary part of this. So let me show you how to work through this. And in particular, I'm going to use the properties of the conjugate or the complex conjugate. In particular, this part here. If you take a complex number and you take away its conjugate and divide by 2, you get the imaginary part of the complex number, say Z. Okay? All right, so I'm going to let W be the complex number, that is Z plus I all over Z minus I. Okay, and if you call this, say, star, we know that the imaginary part of W is 0. All right, so from star and applying the properties of the conjugate. And I discussed these in the previous videos. We have the following. Okay, so 0 is the imaginary part of W. And we know from this identity here, just with Z and Z bar replaced by W, it's the imaginary part is just W minus W bar all over 2. Or just a half of W minus the conjugate, W bar. Okay, well, let's go back to what W is and replace W with Z plus I all over Z minus I and work out what its conjugate is. Now, in each step here, what we're doing is using the properties of the conjugate. So I'm going to be a little bit careful here. Okay, so I'm taking the whole conjugate of this quotient, if you like. Now, I know that the conjugate of a quotient is the quotient of the conjugates. Here it is here. Okay, so I can basically take the conjugate of the top and the conjugate of the bottom. Okay, so let's take the conjugate of the top. Okay, and this is division now, and the conjugate of the bottom. Okay, hopefully that's clear. Okay, now the conjugate of a sum is the sum of the conjugates. That's here and here, or difference, okay? So I can break these two things up into sums of conjugates and differences of conjugates. Okay, so we can keep trying to simplify. What is the conjugate of I? The conjugate of I is negative I. And the conjugate of I again is negative I. So up here we're going to get Z bar minus I. And down here we're going to get Z bar plus I. Okay, so now we can see if we can simplify. What I'm going to do is cross multiply here. So this times this minus this times this all over the product of the two denominators. Okay. Now, in my denominator, if you look up here, here, the denominator is going to be Z minus I multiplied by its conjugate. So the denominator is going to be real. Okay, it's not going to be complex valued, it's going to be real, because I know if I take a complex number and I multiply the conjugate, I always get a real and non-negative number. Okay, so the bottom part is not going to be complex, it's going to be, or imaginary, it's going to be real. Okay, all right, so if I go through, Z bar times Z plus Z bar times I plus I times Z plus I times I, and Z times Z bar, Z times negative I times Z bar, negative I times negative I, and include the minus sign, then I'm going to get the following. Okay, it's a bit of a mess, but let me write it down now. I've taken the liberty of doing a little bit of simplification here in this step. Okay, the I squared will give you -1 there. And then for this sort of cross multiplication, it'll be Z times Z bar. And you're going to get Z times negative I minus I times Z bar. So you get this. And you're going to get negative I times negative I. Well, that's going to be the same as I times I, which is -1. So I'm just going to squeeze that in there. Okay, so that's an I, and I've got a -1 on the end there. Okay, and it's going to be all over this times this. Now, I could work that out, but actually what I'm going to do is just keep it as Z minus I times the conjugate of that, because then I know for sure that that's a real number. Okay. All right. So it looks like a bit of a mess now, but if you carefully look at each term, you can see you're going to get some cancellation. So the Z bars are going to cancel. There's a -1 there. I'm going to get a +1 in there, so they'll cancel. And I'll get 2 times the thing involving Z plus Z bar bracket I. Okay, so we do have a little bit of cancellation now. Okay, obviously the halves are going to cancel. Now let's see where we are. We've done a lot of calculations here, and we've got down to the following. We've got 0 equals Z plus Z bar, all bracketed, times I, all over some real number. Okay, so what this means is that this thing here has to be 0, right? Why? Because on the right-hand side, we've actually got essentially you've got a real, an imaginary number, complex number if you like, purely imaginary, equals 0. That can only be true if this coefficient, so to speak, is 0. In other words, Z plus Z bar equals 0. Or what does that mean? Well, we know this relationship here, Z plus Z bar all over 2 equals the real part of Z. Now we know this top bit's 0, so that means the real part of Z has to be 0. Okay? So it was quite a lot of effort to get to that final step, or the conclusion. Okay, let's just recap that once again. We're given this information and we want to show that the real part of Z, whatever it is 0. Okay, I'm going to use the aspects of the conjugate, introduce this new W to simplify the notation. And the crucial step is to realize that the imaginary, is to use the imaginary part of W is a half times the difference between W and its conjugate. Okay, and then you simplify and use the properties of the conjugate. So here we used the conjugate of a quotient is the quotient of the conjugates, the sum and difference properties for conjugates, and then we simplified, cross-multiplied, looked for cancellation, and lastly we use this kind of relationship between the conjugates and the real part of a complex number. Okay, so a bit fiddly, that one, not easy, but we got there. So hopefully you can see from this presentation that the conjugate and its properties are really useful for simplifying potentially difficult or using the conjugate when we want to prove something. Okay, so it's worth learning about. Now in other forthcoming presentations, I'll talk about more examples that are on a similar difficulty or involved scale as this one. So I hope you can join me for those presentations. If you have any comments, any questions, any feedback, I'd love to hear it. So thanks for watching. Join me again for the next presentation on complex numbers. Bye.